Okay, so the first thing I'm going to do is take up the test in stages. We're going to do a few questions at a time. What I want you guys to remember is that you have to have strategies for taking a test. And I noticed that not a lot of you guys use strategies. And these strategies are very important for high-stakes tests. So what I want you guys to do is just follow along as I take up the test and see some of the things that I use to help me organize my thinking. Okay, so it says a chemist has 2 blocks of sodium. The first block has a mass of 15 grams and a volume of 15.4 centimeters cubed. The second block is half the size of the first. Okay, so you imagine you have 2 blocks of sodium. There's a big one, and there's one that's half that size. But here's the thing, that information is not important, because here's why. The knowledge that you needed to have was that it doesn't matter what the size of the sample is. The density of the sample is always going to be the same. So whether you have 15 kilograms of sodium and 5 kilograms of sodium, both of those things are going to have the same density. So that is a sample independent property, okay? So all you have to do is calculate the density of the one block, and that's going to be the density of the other block and any other subsequent blocks of sodium, because that's a physical property of sodium, its density. Okay, so then you're going to do 15 over 15.4. Now you could use a calculator for this, but this is where you guys have to have your mental math come in. Okay, so 15, it's going to be less than 1 because the number on the bottom is bigger than the number on the top, okay? So then you have these 2 choices. This one and this one. And if you look, the units do not agree, okay? So that takes out those completely, because 0.49 would mean the top number would have to be half as much as the bottom number. And this is almost the same, so it's going to be close to 1. So that's where mental math comes in. You can use a calculator if you like, but it would be a good idea to get those kinds of relationships in your head. Okay, let's go on to the next one. It says Shirley has 3 containers of different liquids. One container has vinegar, okay, and here we see vinegar. One has canola oil, and the third has corn syrup. Here's the corn syrup. She measures the mass and volume of each substance. Well, if we look, it says mass and volume. So it gives the mass of each of them and the volume of each of them, so that's good. She then pours each liquid into a beaker. Shortly thereafter, the liquids separate into layers. Here's Shirley's chart of observations. What will Shirley notice when the liquids separate? Okay, so the knowledge that you need to have is when you pour all these things into a beaker and they settle out, the one with the most density is going to be on the bottom, the most dense, and the least dense is going to be on top. Okay? And so what you should do is figure out the density. Now, you can do it with a calculator, or you can just simply use your mental math, okay? So cross out 2 zeros. 3 divided by 10 is 0.3, and that's grams per milliliter. 25, so it's going to be 0.25 grams per milliliter, because don't forget you move the decimal over by how many zeros you have. And right here it's going to be 0.55 grams per milliliter, okay? So let's look at these things. Well, you're going to have 0.25 is going to be at the top, then 0.3 because it's a little bit more dense, and then 0.55 down at the bottom. So this one's going to be on top, okay? The corn syrup will be at the top. No, we know the corn syrup is going to be at the bottom. The vinegar will be at the top. Look at the vinegar. No, the vinegar is going to be in the middle. The canola oil will be at the top. Yes, that's what we found. And it says the vinegar will be at the bottom. That's not true. Okay, so see. So see, you have to work through and mentally see this kind of stuff. And if you don't, draw it, please. That is a good strategy, okay? Sometimes logic will get you out of a bind if you're not really sure of the material. Okay, so it says Nick enjoys a drink that his babushka used to make for him when he was young called kvass. It is brewed from a delicious bread, blackcurrant leaves, yeast, and sugar. Okay, so here's where we're thinking brewed. That sounds much like tea because tea is brewed. The ingredients are steeped in hot water, much like tea is steeped. The mixture is then strained over a glass through a filter. So here in your head, you should imagine that there's a filter in here, and there's a glass. And all of the ingredients, the bread, the blackcurrant leaves, yeast, and sugar, they're all sitting here in the filter. And then you pour hot water over it. What's going to happen? Well, the water is going to make its way through the filter, but all of this stuff will get caught up in there. Okay? So down here, you would have probably a delicious liquid by the sounds of it, but you wouldn't have any of this stuff because it would get stuck in the filter. Okay? So a compound, it is not a compound because it's not made up of elements. A mixture would be something that has more than one type of matter, so it could possibly be a mixture because it's got a bunch of stuff in it. A solution, yes, it could be a solution. An element, no, because an element would have to be something from the periodic table. So now we're looking at these two things, and a lot of times you have to find the best answer. And it says the mixture is strained over a glass through a filter, so that means it comes from something that's heterogeneous into something that's homogeneous. So solution is the best answer for that one, because solution is a homogeneous mixture. Okay, Olivia has 4 samples of a white crystalline powder. By all outward appearances, the substances are identical. Her teacher insists, however, that all 4 substances are different. Which of the following would not help Olivia determine what each substance is? Okay, and this is where you have to know your physical properties. Now, the density of each substance is different for each of the substances. So let's say we have salt, sugar, baking soda, and, I don't know, calcium chloride. Okay, so those are the 4 substances, and they're white powders, okay? So the density of salt is different from the density of sugar, which is different from the density of baking soda, which is different from the density of calcium chloride. Each of these has their own density. So that would actually help her determine the identity of the substance. The mass. Now, if I had different types of mass of each of these, I wouldn't be able to say, oh yeah, the salt is the one that's 4 grams, the sugar is the one that's 3 grams. The mass wouldn't tell me anything about what the substance is. It would just tell me how much it is. So that is a good example of something that would not help me determine the substance. The melting point. Each of these substances has their own melting point. And the melting point of salt is different from the melting point of sugar, which is different from the melting point of baking soda, and different from the melting point of calcium chloride. So that wouldn't help me, that would help me determine what the substance was. And conductivity, each of these has their own conductivity. So that would help me. So I'm looking for things that would not help me determine the substance. So there we go, it's mass.